Okay, welcome back. Today I'm going to be doing an annuity question. We're going to look at this is kind of a complicated question, but we're going to look at it and we're going to see if we can understand it. So, the present value of an annuity due is greater than the present value of an ordinary annuity. Okay, so and it's asking us if it's true or false, if this is true or false. So, let's write down the formulas because this is more of a conceptual question than a solving question. So, an ordinary annuity has the formula A is equal to R multiplied by 1 plus I to the power of n minus 1 on top of I, right? So that seems simple enough. Next, let's look at the formula for present value of an annuity. So present value of an annuity. Okay, so when you have present value, you know that the formula is PV is equal to R 1 plus I to the power. Oh, sorry. No, it's not. Okay, so yeah, just like I said, I made a little mistake here in the formula. It's 1 minus 1 plus I power of negative n divided by I. And now, what the question is asking us is the present value of an annuity due is greater than the present value of an ordinary annuity. So the present value of an annuity due would be the present value of an ordinary annuity we know is this little number right here. So we will isolate for that number, and if we do that, we get A into I. Oh, sorry, hold on. No. Okay, so let's get back to it. My bad, I was sorry about that pause. Okay, so I was making sure I was doing this right. Okay, so 1 plus I to the power of n minus 1, and then this is equal to R, right? So is this value greater than, in this case, it's a little more complicated to get the R value, so um, well, in this case, we're not solving for the R value, we're solving for the present value of an annuity due, right? So the present value of an annuity due, So what my interpretation of this question would be that it is asking us for the present value of an annuity due. So this is what it's asking us for. That's what I would assume for it to be. So I would isolate this question in terms of PV. So what I would do is next I would have this. Let's go this over so I have more room to work. I'm gonna have R is being multiplied by 1 minus I. So we know that this is 1 over 1 plus I, right? Sorry about my writing. It gets a little tilted sometimes. Okay, so over I, and then we have that. Then we have equals. So we have R is equal to 1 into 1 plus I to the power of n minus 1 on top of 1 plus I. As you can see, this is really a lot of grunt work, I would say. And now we can multiply the I on the bottom with the I on top. Did I do this equation? Oh, okay, I did, okay. Okay, so now you have, multiply that up there, so you'll have 1 plus I to the power of n minus 1 divided by 1 plus I times I. Let's just write, we have I plus I squared at the bottom now. So now we can look at our all multiplied by R. Let's look at our values now. I think we've isolated it to the point where we can compare it now. So our other formula is so now we have these two right here. So we have A into I divided by 1 plus I into n minus 1. So in this case, we look at this and we see that this is all being multiplied by R, whereas this is not being multiplied by R. So that's, and then we have, okay, so let's assume that the values of I of I is 2. This question is throwing me for a loop. 1 second. See, what I'm confused about right now is whether we're supposed to find R or whether we're supposed to find PV in this case. See, because I'm assuming that we have to compare, R to R, not R to PV. But in a present value, your present value would be the amount that you take out of that you take. So let's think this through. Present value is the amount that you take out of the bank, for example, as a loan today. And then R would be how much you have to pay back monthly or however, whatever your payment intervals are over a given period of time in order to pay that back. That's what R is. And then I, we know to be the interest rate, and then this is the amount of times you want to pay. So, and then in this case, R is the payments that you make once again. So R is the payments that you make monthly, and A is the amount of money you'll have after a given amount of time. So okay, so R is essentially the amount of money that you'll pay monthly. So if I look at my formula sheet right now, what I have is R1 plus I to the power of n minus 1 over I. Okay, so I'll admit it, this question has thrown me for a loop, but I think I think we've compared the incorrect, or I shouldn't say you guys, but I've compared the two things I've compared them incorrectly. So if I take PV and I take R, I should be comparing only present value formulas. So only present values being compared. This has nothing to do with it. I would think that is what's going on right now, just from what I see. Sorry about that. So I think what it's essentially telling us to do is compare to A. Sorry, it's to asking. That's the only thing I can come up with for this question. I mean, essentially, if you compare A to PV, then in this case, what you would have is not AI. You would have A is equal to R bracket R bracket 1 plus I to the power of n minus 1 over 1 plus, sorry, not 1 plus, just I, right? That's the formula for an ordinary annuity, 1 plus I to the n minus 1 over I. And on this side we have 1, so hold on, I made a mistake here as well, because no, wait, no, it's the common denominator is 1 plus I. So if I looked at this here, I have 1 minus 1 over 1 plus I, right? So if sorry, to the power of n. So if I common denominator that, I do 1 plus I to the power of n minus 1. That's the one that we have all on top of 1 plus I. And then if I do reciprocal of this and multiply it, I get 1 over I, which I multiply here. This stays as 1. So we don't really need this 1 here, but it's fine. 1 plus I to the power of n minus 1, all on top of 1 plus I squared, because we're multiplying I, right? Sorry, I plus I squared. Make that more obvious. So now if I look at this, I can see the differences. So what the difference that I see here is that this value, this A value is so the top values are the same for both. So the numerators are equal, right? So it's 1 plus I to the power of n minus 1, so 1 plus I to the power of n minus 1. And then in the bottom, however, the denominators are different. And it's quite obvious that we can tell from the denominators that the denominator of this equation, so 1 plus I squared, is greater than just I, right? So what we have